Cloud. Share my screen. Share. Let's see. Stop sharing. I share. Let's not do share. Okay. All right. Thank you. Come on in, find a place for yourself. All right, I guess we can start now. First of all, thank you for your interest in this AI Builders Live. My name is Eric Du. I'm professor at the University of Florida, and I'm affiliated with 3 departments, civil engineering, mechanical aerospace engineering, and industrial system engineering. And here with me is my postdoctoral researcher, Dr. Fang Xu. And so in our lab, I do research in the area of robotics, automation, and also AI safety, which is more how we can design safer and better AI systems. And Fang is working a lot on AI agents. So we started to have this idea of having this AI builders class, maybe from last year. And first of all, this is not a class about teaching you how to use AI, how to use ChatGPT, for example. This is a class that can be quite challenging. I want to put this, day one. So this class will cover a lot of mathematics behind AI. So we will teach something called architecture. The architecture is, for example, you know how to use facial recognition. Behind that is probably something called a convolutional neural network. And what is convolutional neural network? How it looks like, how mathematically it looks like, and how we can code that. So that's the core of this course. And with that said, I originally told Principal Dai that I want to focus on at least the grade 7 and beyond, because the students, you should have some level of understanding of at least, algebra. But I also got some, text message from the parents saying that they have some 6th graders who are pretty good at math. So I just say, okay, come and let's see if they can accept this, right? So this level for computation. Okay, and also one thing I want to make very clear is this is also not for fun. This is for AI computation. Okay, the reason I'm doing that is because last year I coached. Let me see. Hold on once here. Last year I coached a team participated in this first ever presidential AI computation. So this is the first ever starting last year, and we made through the first phase, and we actually won the state championship. So we were one of the 5 state champions in terms of AI computation. And then we made to the judging phase. Basically the challenge organizers invited the 3 judges, and we did this online judging interview. And surprisingly, one of the judges from a major tech company, I wouldn't mention the name, but from one of the major AI companies, asked 2 questions. The first question is, tell me the difference between a VIT encoder and a text encoder. How many of you understand this? Okay, and also I want to remind you, actually Dennis was one of the members, and I want to remind you that the judges were very aware that they are facing a bunch of 12-year-old kids. So they're still asking this kind of question. And the second question they were asking was, explain the principles of Bayesian belief networks. So that reminded me, the AI computation, the AI challenge is not as simple as using AI, but you should have the knowledge and skill sets to be able to build AI yourself. And in order to do that, it's more than programming. It's more than knowing how to use Python. You have to know all the working principles behind what we call the AI architecture. I also want to mention this. So there's an emerging challenge called the International Artificial Intelligence Olympiad, and the US branch is the USA Artificial Intelligence Olympiad. It started in 2024, okay? And this is a real question from last year, 25 points. Run the following starter code, import Tor, and also import something called ResNet 50. This is called residual network 50. And then the question was, tell me, how did you calculate the total number of parameters of this model? And also, if the input shape is B3 224, 224, tell me the shape of output. Okay, what is this? What is this challenge? This is a new one that is gaining momentum right now. And I can tell you last year, there are 3 rounds, by the way. The first round happened in local. You can register anytime as far as you are 20-year-old or younger, okay? It doesn't differentiate middle school, high school. No, it didn't care about that. It doesn't care about that. It just, if you want to register, you register and you do that. Round 1, if you make to round 2, you went to MIT and there's a cap there. And if you make to round 2, you go to Harvard, there's a cap there. And they pick 8 people to represent the US team and go to the International AI Olympiad. All 8 people went to MIT. That's what happened last year. So that's the level of the challenge, difficulty. Okay, in order to understand this question, how to answer this question, even understand this question, you have to understand this. This is what the ResNet 50, it's a U-shaped residual network with multiple, what we call convolution layers. But in order to understand that, you also need to understand first, what is a neural network? So there's so many knowledge points that we have to cover to make the kids understand that. So that is for challenge. But what's more, we are not living for challenge, right? We are not living for computations. Why this is becoming more important nowadays? Here's why. So you guys probably heard a lot about computer programmers, the job being affected by AI, which is understandable because now ChatGPT, Codex, Claude, they can all program for you. That's true. Here, the data actually shows that 19% of the fresh entry-level computer science graduates couldn't find a job in computer science. And this number is even higher than liberal arts graduates nowadays. So that's why we start to see a lot of our computer science programs start to cut their program. They start to shrink the size of their program. But meanwhile, here is the data showing AI engineer jobs. It's increasing dramatically. So basically, we saw these 2 extremes. The entry-level programmers or developers, the industry is cutting, the size. But for the high-end, high-level AI engineers of who can develop AI models, the need is there. It's actually the #1 faster growth, job market. So the difference is who can build the model, not who can use the model. And in terms of the AI engineer landscape for their career, the average salary for AI engineers, by the way, is AI, not programmers, okay? They are very different nowadays. So the average salary is more than $200,000. That's a starting salary. And for one supply, they have 3 opens, which means they are missing 2. They are short of 2 people to fill all the remaining gaps of AI engineers. And also some very interesting cases. For example, we saw a lot of younger kids entering this industry. So because of AI, the tradition of education has changed. Usually we consider you have to go to college to spend 4 years and learn something, or even go to graduate school and learn something, and to become an expert and find a job. That is too slow. We found something that is very, very different. So for example, this is the case, this kid actually got a job from OpenAI as an AI scientist when he was a high schooler. And this guy started programming when he was 7 years old, and he sold his app for $40 million just because of he knows the need, and also he knows how to work with AI. So we recognize the need of building AIs instead of just using AI. So this course, or this live, or this whatever camp, is not about a prompt engineering or using ChatGPT, okay? So I saw, by the way, my son took a class last year. So I wanted him to get exposed to AI. So we registered this online course for him. The title of the course is called Python for AI, but it's nothing. It's basically Python course. It's basically teaching you how to draw a circle, how to control turbos and move certain, language like animation. And by the end, the course actually, the online course used some kind of a chatbot API and ChatGPT you call ChatGPT to answer some questions. That's not building AI. And this course is not about Python programming. Of course, you have to be able to understand Python, but it's not about teaching Python. This is not a Scratch course. That's what I said. It's not fun at all. And this is not an AI introductory course on demonstrating the use of AI. What is this about is the mathematics and the mechanics inside the model. The PyTorch and TensorFlow hands-on projects with them, and computation problems, and also finally a finished application that you build from this course. So in terms of the setup of the course, we will cover 50% time, we will cover the theories, the principles. And that will be me, mainly me. And the other 50%, my postdoc fund will be teaching the use of a Google Colab to program those AI functions. And the reason we pick Google Colab is number one, you don't need a fancy computer to run this. Google Colab is an online service. It costs and uses the cloud resources from Google. Second, a lot of AI computations require you to use Google Colab. So for example, the USA AI Olympiad ask you to even provide written answers inside Google Colab. So you have to be able to use Google Colab. I want to give you one example how that looks like. And don't be scared by the busy screen here. This is something called artificial neural network with 2 hidden layers. This is probably the building blocks of many AIs. And this network, what this network can do is you take a handwriting number and it cuts into patches and basically flatten that as some kind of input, and then send the input to 2 hidden layers, and based on some kind of a calculation, okay, this is called a forward propagation, and it can predict what the number is, either 0 or 7 or all the way through 9. So this is something called AI architecture, okay? This is how we design AI. It's kind of like playing a Lego, game, and this is one Lego piece. And the more complex and more advanced AI models are basically based on the combination and the stacking of all these building blocks of simpler AIs. You may ask how it looks like it's just a graph, but how do I code it? Here is exactly the Google Colab coding for realizing that architecture. As you can see here, this layer, the input layer, is realized from here. So basically, we import all the functions, and this particular function is called flattening, which is, for example, here, this 28, by 28 pixels. Then I basically take each pixel and put them in a single line. That's called flattening. Make sense? And then I send those numbers to those layers. And this line of code is doing that. Okay? And then the first hidden layer, second hidden layer, I have this activation with 64 neurons. Each dot here is called neuron. And then this line of code is doing that. And the dense means everything connects to everything. That's called full connection. And we use that dense. And also it has something called activation, which we will be covering in this line. And then this layer is realized with this line of code. As you can see, first, you understand what this model is doing, what is the architecture looks like. Second, you learn how to write down as scripts in Colab. And that's AI development. That makes sense to you guys? Okay. But of course, if you see here, that's called a training data. So because whenever you are using AI nowadays, the AI has been trained already. But as an AI builder, as an AI developer, you have to train your model by yourself. And in order to train a model by yourself, you have to find the training data, okay? And you have to find a lot of good training data. And so a lot of AI coding, the first step is to download the training data, clean them up, patch them, whatever you need to do, and then cut them into training data side, validation training data side, and testing data side. And all the things is just data processing, okay? And then you send the model, you run the training, the AI model is being trained. For example, here, it's a model training, we do the training, and then once the model is being trained, you can use the model as what you're doing every day. So where to find the training data, how to clean up the training data, that's also one of the skill sets you need to have as an AI builder. Unfortunately, nowadays we have a lot of open source training data that we can download from Hugging Face. And also you can download a lot of trained AI models from Hugging Face. So that's a quick view of why we want to start this AI Live. Like I mentioned, my goal is to try to insert as much knowledge as I can in 3 months, but I know that's not enough. So maybe you have to repeat sometime. But by the end, I really want to pick the best from this class and form teams to participate in next year AI challenges, especially, for example, have this presidential AI challenge that we can form different teams. One coach can coach multiple teams, that's good. And we'll also have different tracks. Some track is more researching a societal problem and you write your design of AI model. But the other track is you have to develop and deliver an AI model. And if you made through the first phase, each kid will receive $500 award. If you made through all the way to the White House, you receive $20K each kid. That's a monetary award. But more important than that, last year I really wanted the kid to go to White House, because if you made through the last phase, you are invited to the White House. You present your project over there. I really want to do that next year. I know that we were very close last year. It just, we were not prepared for that level of depth of all those questions and also all challenges. Another challenge I'm considering is actually the AI Olympiad, and that's something still very new to me. I started the real questions from last 2 years, and by the way, it's new. It started in 2024, so all the data I have is just 2 years worth of data. But fortunately, I think that's doable, because many of the questions just the building blocks of your understanding. So for example, some question could be, I give you 2 matrices and ask you to run something called inner product. How many of you actually have learned inner product or dot product? Okay, we have somebody understand already. So basically the idea is, okay, I give you this one. I want to see if I want to calculate the closeness of 2 vectors. Do you know what to do? Do you know, oh, I need to run this inner product, right? And how to interpret the result. That's all this USA AI Olympiad is about. But you have to be able to write the code inside Google Colab and submit your results inside Google Colab. Okay, so I'm going to go over some of the AI models we would be covering this semester. But before that, do you guys have any questions? And by the way, this room is really hot inside, so sorry for that. Any question before we jump into some of the specific examples? Okay, if no, let me. Okay, so we'll be covering some fundamental and quite important AI architectures. We have this node here. Here. Okay. Okay, so the first thing we want to cover is, let me enlarge this cube. And I'll probably make this one a little bigger. Okay, the first thing I want to cover is something called artificial neural network. It all started in the 1950s. And nowadays people call this a connectionism, connectionism method. It's basically using some neurons and also the connections, which we call the edge, to convert input data into output data. So for example, the input data could be your handwriting image. The output data is recognized number. How this is working, we don't know. That's why a lot of people call AI black box, but it's working perfectly. And the reason it's working perfectly is we assign some numbers to those edges, which is called weight. Okay, and also of course we add something called bears, and also we add something called activation formula. And the magic happens when let me see if we can find the one. The magic happens when you are sending those numbers to this artificial network. All the neurons do is actually very simple to add the numbers together. Okay, so it's kind of like, for example, I'm one neuron and you guys are the input neuron. You give me some numbers. What I do is take your number times the weight we have. Take your number times the weight we have, and take your number times the weight we have. Calculate the total number. That's all it does. Okay, and then I got this number. I send it to a formula called the activation formula. I got a new number, and I send the new number to the next neuron. Okay, that's all in functions about. And then we do something called a backpropagation, because, for example, your handwriting is number 7, the prediction is 1, so something is probably wrong, right? Then I go from the result and go layer by layer, go back to the neurons and ask the neurons to correct the weights. So, for example, the information you give to me somehow always mess up my prediction. And what should I do? Reduce the weight here. That makes sense? So basically, I'm not trusting you that much anymore, so I reduce the weight. So, but if the number you gave me is very close to 7, for example, the number you gave me is very close to, like 6, then guess what I do? I increase the weight. Make sense? This back propagation, and we do forward propagation, and I predict number again. Last time predict 1, this time predict 5. It's closer, so which means the direction of change is correct. So I keep doing the same thing. After several iterations, my number is very close to 7. That makes sense? This process is called machine learning. You probably have heard about AI and heard about machine learning. Talking about the difference between AI and machine learning, a lot of people have different answers, but my answer is AI is the function, machine learning is the process. Okay, so you use machine learning to realize the functions of AI, and machine learning is very simple, but it takes a lot of computing resources. That's why the storage is super expensive nowadays, and also the graphic cards are super expensive nowadays because we are using them to run all those very simple arithmetic calculations. Nothing fancy. It's just adding things, multiplication and everything like that. That's all it does. So we do that, but also a very important thing that a lot of people don't quite get is something called activation. So here, what is activation? So for example, I take number from this neuron and times the weight, I calculate the total weighted summation. And before I throw my number to my next neuron, for example, to you, I always use a formula to process it. For example, this formula, what does formula do? It's max 0 or x. What does it mean? It's whatever number. So basically, if my number is negative, then I pick what number? Pick 0. If a number is positive, I pick my number, right? Or for example, this is a sigmoid. X is my number. I put that in this one. This is exponential calculation, and then this is a very simple formula. And I generate a new number and I give to the next neuron. That's right. You guys understand what's going on here? Now, quick question. Why are we doing this? Why can't I just give my raw data to this neuron? Anybody?
The neuron isn't able to process raw data yet?
The neurons can process whatever data you give to them, but why are we designing such an additional layer of filter to filter or distort the information before we send the information to the next neuron? For the sake of time, I'm giving the answer. This is about nonlinearity, because when we are talking about taking a number times a weight, taking a number times weight, what I'm doing is linear. It cannot store that level of information complexity. I have to add additional layer to add nonlinearity to make the things fancier, and the AI or the whatever container of information can learn more complex patterns. It's a Python machine. Make sense? So with that said, why do we have so many different activation formulas? Because we have different needs. We want the AI to present different behaviors. So here is the lesson 101. As an AI builder, you have to be able to understand what behavior you want from your AI model, and then pick the right building blocks, such as the right number of layers, the right number of neurons, but also the right choice of activation formula. That makes sense? Okay, we'll be covering more here and give you more specific examples. And of course, we'll be talking about some fundamental preparation, like I mentioned. When we want to train AI model, we need the training data, correct? But why do we need to cut training data to, for example, 80% training data, 20% testing data? Why are we doing that? Because there's a fundamental problem about overfitting. What is overfitting? if I give you guys the same mathematical questions over and over again for a year, and next year I give you the same mathematical questions, ask you to give the answer, you guys probably memorized the answer already, right? It's A, C, D, B. You don't think. Same thing happened to AI. If you give AI the same amount of data, train the AI, but you're using AI also with the same data, the AI can always give you perfect results. That's the AI is not doing any prediction. The AI is only memorizing. So the reason we are processing data is to avoid, the fundamental reason processing data is to avoid overfitting. But we also have a validation phase is to test if our architecture is well designed. So do we need to change the architecture? Do we want to reduce something? Do we want to increase the dropout rate? The dropout rate, by the way, is I really don't like your answer. So I'm going to totally cut our ad or our connection. So I'm not going to receive any information from you. And if I have 3 neurons, I cut 1, the dropout rate is 33%. That makes sense? So that's all the design that we could have when we are designing or building an AI model. And also, we'll be covering something very traditional. For example, support vector machine. What is support vector machine? Let's say you go to doctor, you do some lab test. And based on that, I send the lab test result to an AI model to tell if you have a COVID or not, okay? Sometimes, for example, all the yellow dots means you have COVID, all the blue dots means you don't. But sometimes it's very difficult for us to find a way to tell the difference, right? So can you see everything, for example, if this is number 5, can you say that all the results greater than 5 means they have COVID? No, because greater than 5, you also have some yellow dots and some blue dots, correct? Then we play something called a kernel trick. And we first do something called a kernel mapping, which is, for example, if we can find a mathematical projection formula, project this 2D data representation to a 3D representation, and see what happens. All the yellow dots and also all the blue dots is separate, right? And then I can find a single plane. This is a hyperplane, very simple representation of a formula. Then I can differentiate those 2 groups of patients. And this is called a support vector machine. It's very popular, widely used in all kinds of classification problems nowadays, especially medical science. The kernel trick is a mathematical way of reducing the need for computation, okay? And so we'll be talking about that, but I want to show you the level of difficulty of that, with some kind of real examples that how the kernel trick works and why do we need a kernel trick, what kind of a saving we could have from kernel tricks. Why I'm doing this? Because that's a real problem, real question from previous AI Olympiad, problem. So they asked this question, explain to me the kernel trick, or tell me what this kernel trick is about. So that's that. And then based on that, we'll be covering something called CNN or convolutional neural network. Your phone can recognize your face, okay? And also now you present to an AI like a smart camera, it recognize this is cat, this is dog. Behind that, the algorithm is something called convolutional neural network. So 430, okay. This is actually a perfect tool for processing images and also sound, because literally, technically speaking, we can convert sound into images. Okay, we can use image to preserve the same information of sound. And convolutional network was very, very popular before ChatGPT. So nowadays, everybody's talking about ChatGPT, but I want to mention to that the entire AI literature was mastered and governed by convolutional network for many, many years, especially starting from 2012. A very smart PhD student invented architecture. Later, we call them AlexNet. AlexNet is named after the person's name, Alex. So that's why your phones are smart. The phones can recognize your voice. Behind that, that's all convolutional network. So then we will be talking about what is convolutional. So here we will show some of the, let me see, where's that? So basically first, we will be talking about how we can convert images into numbers through something called a tensor, okay? 1D, 2D, 3D tensors. And Then we'll be talking about how we process tensor through something called a convolutional calculation. And this example, convolutional calculation. So for example, all those things you are seeing here as numbers, if I can somehow convert them into colors, then you'll see images, correct? All the things you are looking at on your phone, the pictures behind that are just matrix, numbers. And usually you have 3 channels, RGB, red, green, blue. And the usual thing we combine that, that's an image, but behind that, in the eyes of computer, they are numbers. And then we do something called a convolutional calculation, and this is called a kernel. This is our third time hearing the word kernel. Kernel is a formula. Kernel is a function. Nothing fancy, it's a function. And the kernel scan over this original input channel and get a new, representation of original information. And then we will definitely talk about how we run this kernel computation. And then after that, we run this kind of, pooling, which is further reducing the information. And by the end, here's a picture. We convert them into some numbers. And then we use something to predict if this is dog or cat based on only those numbers. And you may ask, why? Why? Is that magical? Because it's just a whole bunch of numbers. How come the AI knows how those numbers represent the cat, not the dog? Once again, machine learning, okay? We run this backpropagation, and basically my kernel is trainable, what we call learnable parameters. What is the learnable parameters? For example, here, this is a kernel, okay? It's pretty much a matrix. And those numbers here are randomized at the very beginning. But after training, those numbers will be different based on the data and based on your need. And the difference between the original random numbers and the final, kernel is training. And backpropagation is to find the best combination of numbers that can give you the best accuracy of prediction. That is called machine learning. And the kernel represents the size of the trainable parameters. We also have pooling, we also have variance. Why is this important? Because the exactly same question, the old question I showed you in the first slide, the ResNet 50 parameters. It actually asks you to calculate the total number of parameters, learnable parameters inside this machine learning model, which means we have to understand what's going on here to be able to calculate that number, okay? So we do convolutional neural network, and then we will do RNN. So here, this is called RNN. Basically, for example, this is about predicting a sequence of data. The ANN can give you a static result. If you send a handwriting, it tells you if this is number 7 or number 8. But RNN it takes your prediction, send it back, and predict next prediction, send it back. Do you guys know before ChatGPT, you can still talk to your Siri, right? How the Siri is talking to you? Because talking is a sequence of words, correct? It's rely on the fundamental architecture of RNN. So when Siri is trying to talk to you, for example, you ask Siri, what's the temperature today? And the Siri answers, the temperature today, the high of today is 95, okay? First, it predicts the word the, and send it back to RNN. And based on that, it predicts the next one, the high, and send the high back. And then predict next word, temperature, and send it back, and next word. It's recurrent. That's why we call it recurrent neural network. Make sense? So the fundamentals of that is still very similar as a neural network, but the way we code and the way define those neurons are based on their positions in time. Okay, so here the axis time, t plus 1, t plus 2, and then basically program those neurons based on time, so you can predict also a sequential thing. And advanced version of that is something called long short-term memory. It's just a fancier, way of doing. We probably wouldn't be able to cover that, but I just want to show you, the fancier design of AI can be, I jump into the neurons, I define more complex behaviors of the neurons, then I can have better AI models. For example, the key difference between a long short-term memory network and a recurrent neural network is it can forget. Okay, the problem that is if you're predicting a really long sequence of a sentence, the model will be overloaded. You guys understand that? So it's kind of like in order to even predict the last word, I have to send all the previous words to my model. I want my model to be able to forget something that is too old. And this is long short-term memory. And we just design the behavior of the neurons. So I'm okay, now giving the rule here, the regulations here, I want to forget about everything there. So that's actually very simple. As you can see, a lot of AI concept is actually very straightforward, but very smart. Okay, that's that. And by the way, I forgot to mention, after each module, my postdoc researcher, Dr. Xu, will do a lab using Colab. So for example, I finished teaching ANN. Xu will be, Fang will be teaching, how to use Colab to program ANN. For example, using ANN to predict handwriting. And for CNN, it could be we train a CNN model with Colab, then I send a whole bunch of pictures, and the simple CNN model can predict if they are dogs or cats, okay? And the same here, long short-term memory, it could be a very simple chatbot. By the way, my son, James, he's 13-year-old, he programmed the chatbot himself using long short-term memory. He spent 33 hours of my GPU time of Colab and just train a model. And the first response from the model is, "I don't like you." So because of because the models are not aligned, that's another concept. A lot of nowadays the ChatGPT, the product you receive is actually going through something called reinforcement learning from human feedback. It's aligned well, it's polite because we want them to be polite. But a native model, actually they can say whatever they want to say. Okay, that's the beauty. If you want to build a long-term memory yourself, you can always try that, but it can take some money. Okay, it can cost something. Okay, so let me see. Okay, now the key, transformer. What is transformer? Anybody knows that? Okay, great. What is transformer? Yeah, go ahead.
It's something in electronics that my mom sometimes talks about, but I have no idea what it is.
Okay, so this transformer is not that transformer. Transformer has three meanings, right? So transformer can be the movie transformer, right? The thing can convert from trucks, or can be the electronic transformer that sends electricity. The other transformer is ChatGPT. So behind the ChatGPT, that's the architecture of the ChatGPT called transformer. What is transformer? It takes time. So transformer is an encoder decoder structure. Basically, you have a lot of blocks. Those blocks are taking the words and send them to some high dimensional space called embedding space, and finding the Python and send them to something called MLP, and send them to a decoder and generate things. It's amazing. Okay, it's an amazing concept. The reason I call it amazing is because it's so simple. The more you know about transformer, the more you understand, oh, it's such a simple idea, but then it's working perfectly. This is transformer. So in order to understand transformer, first, we need to understand what is, let me see, 160. What is a tokenization? So we are speaking language, the words, but the machine cannot understand words. So machine have to convert words into numbers. Very simple, correct? And that's the first step. It's called tokenization. We convert words to numbers, but the tokens are not words. The tokens are portions of words. Why do we do that? Because we know that some of the portions will be repetitively used in different words. That makes sense? So why don't we just document all the words? Why don't we document the fundamental units of language, which is called tokens? And the process of converting those things into numbers called tokenization. So we do tokenization, and then we do something called embedding. So here is embedding. Embedding is, for example, once you have numbers, we unfold the numbers to even more numbers. I'm just making up an example. 2, 3, 4, 5, 0, 8. That's a number for a word. And then I unfold that to 512 numbers again. So it's not 512 numbers. Why am I doing that? Because I want to picture them. I want to draw a coordinate system with 512x. So you guys know, you guys probably know two-dimensional coordinate system, right? You have x1, x2, correct? If it's three-dimensional coordinate system, you have what? x1, x2, and x3. Okay, that makes sense? Can you imagine x1, x2, x3 all the way to x512? You can imagine, I cannot see that, correct? Why are we doing that? Because language is so complex. If I picture all the words inside a two-dimensional coordinate system, they will what? They will squeeze together. There's no way for you to see the difference or see the pattern. What words are closer to what words? But when you picture them to a high dimensional space, now we're talking about 5,000, 6,000 dimensions, but a simple ChatGPT model or transformer is 512 dimensions. Then this is how it looks like. It starts to have a shape. The meaning of the words will have a shape, but the shape is not predetermined. Like I said, all the AI, all the machine learning stuff is what? Random numbers. So I just threw, for example, I have a 50 words, okay? I have a 50K words. I just threw all the 50K words into this 512 dimension space randomly. And then I learned something called embedding learning. What is embedding learning? This is a really good, interesting example. I want to show you here. Now I'm simplifying a two-dimensional semantic embedding space. And here I have king, queen, man, and woman. And if this two-dimensional space, how many numbers I need to use to identify the position of a word? 2, correct? So that's exactly 2, 3, that's a king, 4, 3, that's a queen, 2, 1, that's a man, and 4, 1, that's a woman. Now, if I want to calculate something called, and if you can see here, it's a king minus man plus woman equals to queen. You guys understand the meaning, right? Somehow you can process the information, correct? Yeah. That's language calculation. We can calculate language. And the vector is the way to calculate that. First, I connect those dots and with arrows that's called vector. And then the magic is king minus 1 is exactly your number minus the mass number is what? 2, 3 minus 1, 2, 1, and I got what? 2, 0. Correct? And if I map to 0, it's here. This new position represents king minus 1, that's 0 and 2, correct? And then plus woman. So 0, 2 plus woman is what? 4, 1. So plus 4, 3. And that's queen. So basically, you do this vector calculation in this high dimensional embedding space, and then you understand the relationship between words. But how can we find the positions? That's what? Learnable parameters. This is called embedding learning. So we learn the embedding, which is I learn where you as a word, as a token, where you should appear in this 512 dimensional space. And I can do whatever I want to do. So for example, here, a very important concept is called dot product or inner product. Fancy word, simple meaning. How close two words are. For example, Apple, orange, and Microsoft. Depending on the context, Apple can be very close to an orange. If I'm talking about Apple as a fruit, but Apple can be also close to Microsoft. I've been talking about that as a Microsoft. How do I know what I'm talking about? I calculate the angle between that. If the two words in this high dimensional space has a smaller angle, which means they are closer in the context, which means when I'm generating a sequence of a sentence, I find whatever tokens that are having a smaller angle. But how can I quantify the angle? Dot product. The dot product is just the norms, which is the length of the vector times the cosine of their angle. And a higher number of dot product means what? Means a smaller angle, which means they are closer. Then I can teach machine how to find the closeness of words, the meaning, the semantic space, and then generate ChatGPT. Okay, of course, the reality is still more complex than that, but this is a fundamental thing that you probably already got. For example, we still have a lot of positional coding, or what we call self-attention. Self-attention is actually how I'm documenting this chunk of sentence and find another chunk of sentence that are closer in this semantic meaning. But the fundamental is how can we convert language into numbers and use mathematics to do that? And that's ChatGPT. Nothing fancy, it's just very fundamental mathematics. And literally, if you want, you can even train and design a ChatGPT level, ChatGPT-2 level model with your personal computer with 2 nights. Okay, but you still have graphic card to train that. And you can find a open source Wikipedia page or whatever the documents can find online and train the model, and the model can talk. Actually, I do have some simpler models in my machine that can talk simple things with me. Very, very simple transformer architecture. So another very important thing, finally, another very important thing that we have to cover is the evaluation of machine learning model. So when we are saying, let me see here. So for example, when we are saying the model is better than that model, or if this model is good enough for me to publish, it's more than just accuracy. This is something called a confusion matrix. So for example, if this patient has COVID, how likely I can predict the person has COVID, okay? And if the person doesn't have COVID, how likely I can tell the person doesn't have COVID, etc. So this is called a confusion matrix, and we have this type 1, type 2 errors, true positive, false positive. All those things will also be covered in all the AI challenges. And we can develop a whole lot of metrics from that, such as recall rate, precision, F1 ratio, etc. But as you can tell, we do have some examples to talk about that. And this is very popular metrics for you to evaluate the performance of model. And that's pretty much, all the things I want to cover. The AI architecture I want to cover this much. As you can tell, it's more than just how to use AI, right? It's the fundamental architecture, the fundamental mathematics behind that. And like I said, after every module, we will have this lab of using Colab. And the Fang actually prepared some quick demo of how Colab can help build simple AI models, and he will show that here. You don't need to share your screen. You can just HDMI. Yeah, this one. Okay, go ahead. Oh, it's not showing. So Colab is an online web browser based programming environment. In order to use that, you have to have a Google account. And I think you guys should be able to use some kind of a free version with minimum access to their cloud server, because we do need their cloud server to train the model. Go ahead.
Yeah, so basically Colab is an online coding platform that you can write code and upload and run it, especially running it with free Google server. It is all free for our case, free is more than enough. And let me just show you some interesting demos I prepared, but with the exact course demos, course codings, I will go over every line and make this very informative and specific. So this one is just like showing you the capability of the Colab. So basically you can edit those codes just as text in your Google Drive, and you just put them text inside and create the Colab page, and it will form this redirect you to this coding page, and you write the code and execute it with your browser. So first demo I'm showing you is an object detection. So we load up some models onto the Google server.
So by the way, the Colab is based on cells, and I believe Fang actually prepared the codes based on cells. So it's a good exercise, a good practice to build your code in the cells, because if you mess up with one cell, you wouldn't affect other cells. So he's writing the code cell by cell. And by the way, like I mentioned, this is a web page, this is web browser based. So you don't need a fancy computer. Any computer then can access Google. That should be good.
Yeah, just so this cell is a code cell, and that maybe next one you can do some annotations with the text cell, and then we can run the second code cell. This one.
What is cell is about?
It's loading up
a lot of functions,
Yep.
reading the files, okay, and then do some kind of processing of the.
Yeah, we told the model to detect objects in this internet downloading the pictures, and you can see many things are detected. Shoes, person, dogs, and if we want to narrow down the scope onto dogs, and we can revise the code and actually So just let the model output the dog's positions. And as you can see, there are many brackets about the dogs. That's because the models are overloading its capability to show you everything suspiciously detected as a dog. So the dog's feet and dog's tails are all dogs. What we need to do next is slightly adjust code, so it will apply a filter, so only more than a certain threshold is detected as a dog. And as you can see, we are pretty much clear about the dog detection. Only one thing, we have a 0.44 trust level detecting box, so we can further increase the trust thresholding to 0.6. And now voila, we have 2 dogs detected, perfect.
So basically, the model has been trained inside the Colab environment, and what the file is showing you that as an engineer of AI, once you're done with your version 1 model, you can keep coding, the functions of that, the filter that to optimize the better performance.
And I'm going to show you another demonstrative code cluster. So this one will load up the Google Media Path model, which is basically a convolutional neural network, and it detects hands. That's the single purpose of it, and it's well trained and very low computing cost, and it runs very fast at a high frame rate. So first one, we need to import the Media Path model to the Google servers or onto this web page. Doesn't need you to run it locally.
And by the way, I want to mention this to you guys. You probably see the status bar here, the RAM and disk.
Yeah.
And this is here to show you how much resources we're using Google Cloud Server right now. And this is Google Colab. So next class, I think it will be Dr. Fang. So 50-50, which means, it's this week I'm teaching, next week Dr. Xu, and next week I'm teaching, and Dr. Fang. So we'll do this iterative way. So next week he will be going through how to set up your Google Colab account and how to set up the use of a GPU or CPU, all the configuration of that, and do a very simple ANN program next week.
Oh, yeah, just keep on going, and we can download the image from the internet and detect the hand pose in image as the hand mesh. So 21 join points as represented for the 21 degrees of freedom of the human hand. So I prepared another live demo. It doesn't run on Safari, so just remember to run it on
Google Chrome.
Google Chrome, yes. This one is more smooth. And if it does run well, have a live detection.
Still is using your web camera, right?
Yes,
Yes, go
using my
ahead.
webcam.
So that right?
It's just
it's running. Okay.
Yeah, it's running. So this error, we need to ignore that. Camera, and there we can see the hand is being recognized.
And like I said, behind that is actually CNN. You guys remember CNN, convolutional network? What happened is, the model takes the camera, cut into pixels, change the pixels to numbers, send those numbers, flatten numbers, send them to do the convolutional calculation and do a pooling, and another convolutional calculation and pooling, and then calculate some numbers, and then output this gesture based on those numbers. So that's convolutional network. All right. Okay, so yeah, you guys want to try it. If you go closer, you can recognize that. Yes. Yeah. Yes, a little bit. Yeah. Okay, I think that's pretty much, what we want to cover today. I think we basically talk about the motivation of having this class, and I hope you guys can tell this class is very different. It's more than just a strategy of coding. It's very heavy. Okay, so that's why I say make a decision yourself. If you want to challenge yourself, if you want to do something, if you believe they can get maybe 20%, 30% of contents.
Yeah, so for the course settings, for example, I think it's really great. I think it's really interesting, but I think I might hold her off for 1 year
Okay,
to really understand the project.
okay.
But for your settings, can you do 1 year and then next year will be the same, or will be kind of going the deeper?
So it's my first time trying this.
Okay.
And I think I'm going to use Mr. Freezer's approach. I can just just try to, squeeze a lot of things because a lot of things they are interconnected, right? So, I have to cover, for example, the model assessment methods. I have to cover a lot of, basic, matrix calculation, even to understand some fundamentals of simpler models. So I will try my best to cover as much as possible. But like you can see, I have a 400-page, material. I wouldn't cover that, probably half of them. So actually, I leave out, for example, reinforcement learning. I leave out principal component analysis. I hate them myself because the mathematics is really heavy related to that. And unfortunately, PCA or principal component analysis is also appear in the previous USA AI Olympics questions. So I guess, probably for this year one test, I wouldn't do that. But like I mentioned, 16 courses, 50 minutes each, it's not enough. So in the future, I'm actually considering to have an online course, which is more, which is heavier, probably like, 1.5 hour each module to cover more. But next year, if you want to repeat, we will pretty much repeat the same thing, but I guess the students will dedicate more challenging tasks. For example, I probably gave the students, if it's a year two students, some real questions to answer. And also, I want to mention year one, if you want to try this year one, I don't think it's a good idea to memorize all the coding, all the, syntax. Year two, you have to, because a lot of AI challenges, they have this whiteboard coding challenge. So they basically ask you to download some software program and a camera to see that what you're working on your hands and also the screen, and they give you the questions, and they want you to use the manual coding, and you are not allowed to use any Google search or Gemini or any kind of a thing. So if you don't know how to code, then you cannot go through, even though you know things. But I think year one is more knowledge preparation. You have to know things, and year two, try to focus on the coding themselves. Okay, so I think that's.
But that's like, for example, if this year's students take this year, to repeat next year, will you take another course? Like you have 2-level course, or it will be all inserted into one?
I think, what I can do is, we will have the, lab module different.
Okay.
So it's always good idea to repeat some of the, knowledge materials, because myself, I keep forgetting about some of the, fundamentals. Every year when I'm teaching this, by the way, I'm teaching a similar class at University of Florida. Every year when I'm teaching that, I remind my refresh or deepening my understanding myself. But the labs will be different. So basically, the year two labs will be, in my opinion, will be more challenging. Like we will get some real questions from the AI challenges and ask students to practice.
Thank you.
Any question?
What are the logistics, like what times do we?
So basically, we have to follow the Chinese school schedule. So starting from next week, it will be 3:30 to 4:20, so 50 minutes. Not 4:30, so 3:30 to 4:20, starting from next week. Sunday, every Sunday here. But it's not enough. So what I'm thinking is, we will try to give some homework, and we will leave an email, and we will answer some of the questions with emails to somehow cover up some of the insufficiency here. And like I mentioned, starting from next semester, I'm actually thinking about at least to make it some portion of that online. So maybe we have some portion in person as well, but some portion online. So I really want to cover enough materials, something we want to go deeper.
So the course goes from now for 3 more months?
So I think it's 16 in total. So 16
classes.
16 classes.
Oh, only.
Yes, yes. Any other question from you guys?
If no one, I have one more.
Yeah.
So what kind of subject are you gonna try to put them to do the competition? More like a multi-module AI, or like a solve the real world problem?
So there are different kind of AI challenges. One of the AI challenge, they want you to solve real world problems, and we cannot define that here now. But the students must be able to discover really good direction of our problems and convince, the judges or the organizers that this is a really good problem that haven't been covered. So that's one kind of AI challenge. For example, presidential AI challenge, they focus on solving the societal problems. But there are also other kind of AI challenge, for example, the AI Olympiad. They don't care. They don't care what the problem they are doing. The question is actually just giving you chunks of codes, or for example, one question is they give you this CNN model and say, now I need to write a code to truncate the size by 50%, which means use one single line of code, not one single line, sorry, use some code to reduce the size of the model by 50%. Then you have to understand when you're reducing this convolution layer, you also need to reduce the max pooling layer, and how to do that, what layers to reduce, and how you can rebuild the connections between the cut layers to the final max, for example, softmax or MLP layers. You have to understand the architecture to be able to answer, but they don't care what societal problems you are solving.
I have 2 questions.
Yes.
So, I'm assuming students are supposed to bring next time
Yes.
computer and a Google Chrome will work because it's Google.
Yes. So next class, and starting from next class, students will need to bring laptops. Like I said, you don't need a fancy laptop, but you need a laptop that can talk to the internet, and you have to set up a Google Chrome.
Google
And
Chrome.
next week, Fang is going to do that step by step. How to open this new Chrome, how to open this Colab environment, configure that, and do. We agreed to do a simple model of handwriting recognition. So it's mini state aside, and you write a number with your mouse, and then the model can predict the number. And by the way, we cannot guarantee a successful model, because the training time is very short. But you guys are going to go through the entire workflow of downloading the data, cleaning up the data, building a model, training the model, running the model. You guys are going to run that. Yes, laptop can run Google, connect to the Wi-Fi here. Yes.
Google account, they need the phone number to register, so please.
Oh, Google account needs a phone number. So you need okay. I guess then before next, if you want to come next week, you want to talk to your parents to register Google account first.
Yeah.
Otherwise, we cannot do anything.
The other question I had is, do you have like a special expectations about math level, programming level, or something like that?
So, it's challenging. I think, for example, when we are talking about some of the functions, I think the students will at least have the understanding of algebra, right? So, we will also cover a lot of a matrix calculation, matrix multiplication. I guess I can try to teach, because they are not that. We're not talking about eigenfactors or eigenvalues, that kind of stuff. Like I mentioned, I don't want to cover PCA because PCA requires a lot of knowledge of linear algebra. So we'll skip that. So for other things, as far as you know, y equals x plus b means what, then I think that should be fine. Or y equals fx and fx equals something, it should be fine. In terms of programming, it's fine. I guess year one, what Fang is going to do is to give you the code online and share that with you. I think the ability is more reading the code. Like, here's the chunks of code, and you understand the meaning of this code, how this section of code is corresponding to the architectural model. That's all. Or this code is for cleaning up the data. That's all you need to understand. But starting next year, if you want to advance to the next level, then you have to know Python. So it's pretty much Python, but a very simple Python.
Yeah.
Nothing fancy.
After the 16 hours of course, what's your expectation of time that students spend?
So after 16 hours of that, like I said, my goal is to teach some teams. Then that requires some dedication. Okay, so I guess the students of you have to work as a team and to study a problem and also design their models. And what I'm going to do is just tell them, this is wrong, this is right. You should make this stronger, or should add this new architecture, whatever. So at least after that, I guess twice a week, we probably, me as the coach and the teams that I have picked, have to meet, But in terms of personal dedication, I think the outcome of this course is, I think the biggest outcome of the course is that kids shouldn't be scared of AI anymore. So AI is not one thing. AI is 100 different things, as you can tell. We have so many different AIs. Okay, we have so many different machine learning methods, and for some advanced topics, we also have things like a learning rate. example, batch size determination, how to optimize that from an engineer perspective. Those things we wouldn't have time to cover in this course, but I'm happy to share that with the students who are interested in. But I think the students should be more confident at the end of this 16 hours that, hey, I know AI doesn't mean some fancy magical box or black box. The AI is just whole bunch of formulas, and the way we combine the formulas determine their behaviors. And then, like I said, I'm considering to open another course next semester to focus on going some more advanced topics. If the students are interested in going to more advanced topics, they are more than welcome to register next semester. By the way, and also it's developing. I hate that. So like every 3 months, there's a new architecture. And last year, last year I was teaching DeepSeek. You know, like DeepSeek actually wiped out $2 trillion from the U.S. Stock market January 2025. And a lot of the politicians here say, oh, obviously because of copycat. And they blame everything to the knowledge distillation. They say DeepSeek company distilled the information from OpenAI, which is wrong, totally wrong. Because actually the truth is the DeepSeek actually developed a very, very smart way for the what we call KV cache, and significantly reduce the total computation need and storage needed by the fold of 100. And also it was invented by senior level college students from Tsinghua University, a girl. The girl actually was majored in mathematics, and she interned at DeepSeek. And she said, oh, the way that OpenAI ChatGPT do this KV cache thing in the calculation is a waste of a space or mathematical space. Why don't I join another thing to represent this whole lot of thing with one number and send one number to the next calculation and unfold number to the original thing. So I don't deliver the entire pack of data to the next phase. So I can save a lot of storage and computing power. And then because of that, they could train a model with only $1 million, and the cost is 1/100 of the US models. That's why DeepSeek wiped out $2 trillion from US market, because those people are smart. They know it's not about knowledge distillation. It's about a very smart architecture. As a researcher, I have to catch up myself. Every 3 months, there's a new architecture. So it's developing, it's evolving, smart people gathering. It's such an interesting and vivid area of research.
So the website, the Chinese school website still gives the time as 4:53:05.
It's only today. It's only today. So because I need to send my son for the ACYO, starting from next week, so we changed the time to 3:30 to 4:20. Yeah.
The method of payment for this, is it Zelle or?
What's that?
How do you want us to pay? Like,
I think it's through the Chinese school.
okay.
Yeah. It's through the Chinese school. I think they have this online payment option. But I have this WeChat group. If you guys want, I guess I don't know how to do it, but we can definitely create a WhatsApp, group and to share information, those kind of stuff. Yeah. If your students are coming next week, I guess we can do it.
What is the Chinese school? I don't know what.
Why Chinese school? I don't know.
What is the Chinese?
What is Chinese? Okay, Chinese school has a long. I don't know if the principal dies here. Chinese school has a long history here. I think it's a 30-year of history. It's formed by this Chinese community to teach Chinese, but also Chinese culture. But now recently I noticed that they also teach a lot of technologies like coding and debate, those kind of stuff. And I really want the first class to be in person. That's why I talked with Principal Dai to see, can I have this class here? And he's so generous, generous enough for me to allow me to do this in person. But then I noticed that the time that allocated to this such a big topic is probably not enough. So we will probably think about something later. Any other questions? By the way, apologize for the temperature is doing so hot. Okay, I guess thank you for coming, guys, and let me know if there's
Thank you.
thank you.
Excuse